Good morning, everyone. So today we are going to talk about experimental and theoretical probability. So experimental probability is the ratio of the numbers of times an event occurs to the total number of trials. So remember, a ratio, you can write that in three different ways. And then theoretical probability is the probability of an event happening based on the possible outcomes. So basically, theoretical probability is just another fancy word for simple probability, what we were doing in the previous lesson. So the main difference with experimental and theoretical probability is experimental probability is asking what does happen, and theoretical is what should happen. All right, so we're going to go over those in this example. So it says, use the spinner below to answer the questions. Then spin the spinner 10 times and complete the table below. All right, so for this first half, we're just going to focus on theoretical probability. So what should happen? So for A, it's asking, what is the theoretical probability of spinning a section with stripes? All right, so how many, let's see, how many sections have stripes? Well, just this one, right? So our numerator is going to be 1, and then we have to put it over the total possible outcomes. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 possible outcomes. So our answer would look like so. So I want to get this converted to a percent, because later when we look at our experimental probability, it's going to be easier to see how close they are. So to do that, you do 1 divided by 8. 1 divided by 8 is equal to 0.125. And to make that a percent, remember you have to move our decimal over 2 places to the right. So our percentage of spinning a section with stripes would be 12.5%. All right, so the second question is asking, it says, what is the theoretical probability of spinning a section with stars? All right, so how many sections do we have stars? We got 2. So we're going to write 2 over 8. However, that can be reduced by dividing both the numerator and the denominator by 2, which now gives us 2 divided by 2 is 1, and 8 divided by 2 is 4. So theoretically, so what should happen is that we have 1/4 of a chance of spinning a section with stars. So we're going to convert that to a percent. So again, we do 1 divided by 4, which gives me 0.25. Move the decimal over 2 places to the right, giving me 25%. So theoretically, there is a 25% chance that this should happen. And for the last question, what is the theoretical probability of not spinning a solid or a striped section? So what is a theoretical probability of not spinning a solid or a striped section? Okay, so not spinning. So I'm going to get rid of cross off a solid and our striped. So, because we're not including solid or striped. So what are we left with? We are left with 2 stars and 1 section with dots. So the probability of this happening, what should happen, it should be 3 over 8. Because remember why it's 8, because there are 8 sections of the spinner. All right, now we got to convert it to a percentage. So we're going to do 3 divided by 8. which is 0.375. Move the decimal over 2 places to the right, and we get 37.5%. So the theoretical probability of what should happen is 37.5%. All right, so now moving on to the next section. All right, so now it's time for the experimental probability part of this. So it says up here, after we use the spinner below right here to answer these questions, then it says spin the spinner 10 times and compute the table below. So I went ahead and created when I did the spinner, I spun once on stripes. So here I'm going to put total number of spins was 1. My total number of spins for white, which is just the blank ones, I got 7. Dots, it never landed on dots for me, so 0. And stars, it landed twice. So to get the experimental probability, it is going to be, so total number of spins that it landed once on stripes. So it's going to be 1 out of 10 because I spun the spinner 10 times, and out of those 10 times, it only landed on stripes once. So then I'm going to convert that into a percent. So remember to do that. You do 1 divided by 10, which equals 0.1. Move the decimal over 2 times, going to give me 10%. So up here, it said, what is a theoretical probability of spinning a section with stripes? Well, theoretical is what should happen. And what should happen is we should have gotten it 1 out of 8 times, so around 12%. Well, what really happened is 10%. That's not that far off. So for white, total number of spins it landed was 7. So it's going to do 7 out of 10. And then to make that into decimal, we do 7 divided by 10 equals 0.7. Move the decimal twice to the right. That is 70%. So 70% that it landed on white, which makes sense because if we look up here, the theoretical of spinning on just a white, well, there's 1, 2, 3, 4. 4 out of 10, that's a 40. So what should happen is 40%, but what really happened, we got 70%. Here we got, for dots, a 0 out of 10, which is just a 0%. So that's not that cute. All right. So if we look up here, for the theoretical probability for just dots, well, there's only 1, so it should have happened 1 out of 10 times. So 10%, and we got 0%. I mean, 10% is still pretty low, so it's not that far off. And then for stars, we got 2 out, so it landed twice out of the 10 spins. And then to make that a percent, you do 2 divided by 10, which gives us 0.2, which is 20%. So if we look up here, stars appears twice. Well, 2 out of 10, what should have happened? It is 20%. What actually happened is exactly the same of what should have happened. It landed on it twice. So that is how we do that. So for your exit tickets, here is your problem. So the first question, Johanna spun a spinner 66 times and recorded the frequency of each result in the table. What is the theoretical probability of spinning an odd number? Write your answer using a slash to represent the fraction bar. So disregard the 66 times for right now. So it's asking, what is the theoretical probability of spinning an odd number? All right, so how many numbers do we have? We have 1, 2, 3, 4, 5, 6. So on this spinner, there are only 6 numbers. How many odd numbers are there? Well, there's 1, 2, 3. So what should happen? We're just looking at this column. We're not looking at these numbers, and we're not thinking about 66. So make sure when you get your answer, you put it, make sure it's reduced in the simplest form. All right, now for this problem, it's asking, what is the experimental probability of rolling a number less than 4? Okay, so experimental probability of rolling a number less than 4. So it's saying less than 4. So we're not going to include 4. So remember, experimental probability is what actually does happen. So it spun 66 times. So you're gonna add the frequencies for the numbers that are less than 4. So you're gonna add those up, and then you're gonna make sure they're written in simplest form. So those are the only 2 questions you guys have for today, and we're gonna do little activity tomorrow on it, which I'll explain more in tomorrow's video. All right, so if you guys need help, try rewatching the video or shoot me an email, and I will get back to you as soon as I can. All right, have a great day.